children, today I am here to teach you chapter 14 in your textbook, that's rectilinear plane figures. So you get two parts here, part 1 and part 2. We are doing both together. So in this part 1, we are identifying what is a polygon is and what are convex and concave polygons. Look at these shapes. A triangle and 4 lines are there. Do you know the name? We are learning that. Quadrilateral. How many lines are there? 1, 2, 3, 4, 5. 5 lines are there. A closed plane figure bounded by 3 or more straight line segments is called a polygon. So here this is a polygon with 3 lines. So all lines are straight lines. And here this one, 4 lines. So that's also a polygon, and here 5 lines, that's also a polygon. So what is a polygon? A closed plane figure bounded by 3 or more straight line segments. So this is a closed figure, so you can color it inside. I want to put a color there. So this is a closed figure. So what about this one? This is another closed figure. And this one, another closed figure. So these all are polygons. Now look at this polygon. 1, 2, 3, 4, 5. 5 straight lines are there. So when you take the point A, we can see point A is inside the polygon, inside polygon. What about C? So this is the polygon. C point is outside the polygon. And B point, it's on the polygon. So you need to know how to identify whether a point is inside, outside, or on the polygon. Check whether these are polygons or not. How can we identify? So when you take a polygon, the vertex point, if we take any point here, connected with 2 straight lines. This point connected with 2 straight lines. Here also 2. When you take a quadrilateral like this, 4-sided one, any point when you take, we call vertex point with 2 lines connected. Here also 2 lines, 2 lines. So those are polygons. Is it a polygon? This is okay, 2 lines. This is also okay, 2 lines. But what happens here? 1, 2, 3. 3 lines are there. So when you get 3 lines connected and make a point, then that's not a polygon. So you can say A is not a polygon. This one, these are okay, 2 lines connected. But when you take this one, 1, 2, 3, 4, 4 points connected. So I can write 4 points, 4 straight lines. 4 straight lines connected. So therefore, B is not a polygon. So that's not a polygon. So how we identify whether it's a polygon? So bounded with straight lines. When you get straight lines, only 2 straight lines connecting and make a point. That's the vertex point. Now we'll see what are triangles. A closed rectilinear plane figure bounded by 3 straight lines is a triangle. So sides of the triangles are the 3 line segments. So we'll take a triangle with 3 line segments. So these are called sides. So this is side. This is also side. This is another side. 3 sides are there. Intersecting points of the sides are vertices. So this is one vertex point. Vertex, the plural is called vertices. So this is another vertex point. This is another vertex point. Interior angle is the inside angle of a triangle formed by intersecting 2 sides. So these are inside angles we call interior angles because those are inside, interior angles. So when you take a triangle, that's a polygon, you get 3 lines intersecting. So we call those are sides, and vertex points are there, and you need to know what are interior angles. Equilateral triangle. Now we'll see what are the types of triangles. If all sides are equal, we can say this is an equilateral triangle. So here, can you identify here 2 lines here? That means equal in length. I can write AB is same as BC is same as AC. All lengths are equal. Small lines denoted that lengths are equal. So this is an equilateral triangle. And if you take the angles, all the angles also equal. Isosceles triangle. What's an isosceles triangle? Only 2 sides are equal. So in this diagram, PQ and PR, 2 lengths are equal. So we call this is an isosceles triangle. When all sides are different lengths, you say that's a scalene triangle. If all the sides are different in length, it is a scaling triangle. So AB is not the same as BC, and this is not same as AC. Totally different lengths. You have given several triangles. Identify equilateral, isosceles, scaling. Equilateral, all 3 sides are equal. Isosceles, 2 sides are equal. And scaling means all sides are different. So we'll take the first one. 3, 4, 5. All different. That's a scalene triangle. B. 6, 8, 7. That's a scalene one. Not equal. 4, 4, 4. All sides are equal. That's an equilateral triangle. 8, 6, 8. Can you see? 2 lengths are equal. That's an isosceles triangle. 9, 9, 7. 2 sides are equal. So that's an isosceles triangle. 2 sides are equal. F. 5, 5, 5. All 3 sides are equal. That is an equilateral triangle. G. 9, 9, 12. 2 sides are equal. That's an isosceles. 11, 11, 11. All 3 sides are equal. That's equilateral. 6, 8, 9. All lengths are different. That's scaling. 5, 7, 7. 2 lengths are equal. Isosceles. 10, 10, 10. All are equal. That's equilateral. And the last one, 6, 10, 11. All lengths are different. That's a scalene triangle. Look at this one. ABC is an isosceles triangle. What are the lengths can be for AC? Isosceles means two lengths should be equal. If one is 7 and this is 8, to get an isosceles, AC can be either 7. Then 7, 7, 8 is an isosceles triangle. Or it can be 8, 8, 7. That's also isosceles triangle. If PQR is an isosceles triangle, what are the lengths can be for QR? 9, 10. So it can be 9 centimeters or 10 centimeters. Two lengths should be equal. This is a scaling triangle. If the lengths of AC is a whole number in between AB and BC, in between 7 and 10, write down possible values for AC. So it can be a different value than 7 and 10. It can be 8 or 9 because this is a scaling triangle. Identify types of triangles examining their lengths 3, 4, 5. All different, scaling. 8, 9, 8. Two lengths are equal. Isosceles. 4, 6, 7. All three are different. Scaling. 11, 11, 13. Two lengths are equal. That's isosceles. 8, 8, 8. All three sides are equal. Equilateral. 11, 12, 9. All three are different. Scaling triangle. 4.5, 6.5, 8.5. All are different. Scaling. 12.1, 9.7, 10.4. All are different. Scaling. 8.4, 8.4, 9.7. Two lengths are equal. Isosceles. 20, 30, 40. All are different. Scaling. Perimeter of the triangle is 28 centimeters. Find the length of AC. So you can do, what is 12 plus 8? 20. So 28 minus 20, you get 8. So AC is 8 centimeters. What type of triangle is ABC? 8, 8, 12. Two lengths are equal. That's an isosceles triangle. So I can write AC is 8 centimeter. What type of triangle? Isosceles. Look at this one. Perimeter of the triangle is 36. Find the lengths of the triangle. So this is equilateral, all sides are equal. If we can divide the perimeter by 3, you get one side. 36 divided by 3, you get 12 centimeters. So AB is 12, BC is 12 and CA is 12. So, because this is an equilateral triangle, look at this diagram. Identify isosceles triangles in this figure. Look at this triangle ABP. You can see that's an isosceles triangle. So you can write ABP triangle. What's the other triangle? APC. So you can see this is another isosceles triangle APC. Look at this diagram. Identify 4 isosceles triangles in this figure. This length is equal to this length. All lengths are equal. So I can take one is AOB triangle. That's one. What about the other one? I can take BOC triangle. I'll put a different color there. That's also isosceles. Another one. AOD triangle. That's also another isosceles triangle. Again, I can write COD triangle. That's also another isosceles triangle. Write down 2 radii in the circle. So here this is the center. Center to any point on the circle we call radius. So 2 radii, OA and OB. Are the 2 radii equal in length? Yes, when you take the compass to draw the circle, this length is equal to this length. Yes, OA is equal to OB. Identify the isosceles triangle now. 2 lengths are equal there. So AOB. AOB is an isosceles triangle. Identify all equilateral triangles in this figure. All sides are equal. So I can first write AQR triangle. Look at the diagram and identify another triangle. BPR triangle. That's also an equilateral triangle. This one. Another triangle. PQR. PQR is also another equilateral triangle. So I'll color that also. Now another one is there. PQC. PQC triangle. What's the other equilateral triangle? When you take the big triangle, can you see each one double of this? So that's also another equilateral triangle. I can write ABC is also an equilateral triangle. Look at this diagram. Identify all isosceles triangles in this figure. Look at this one. These 2 lengths are equal. APQ triangle. And when you take this one, also these two sides are equal. So QRC, CQR triangle, also isosceles. Now take the big one. When you take the big one, can you see? You get double of this. So this side is equal to this side. ABC is also an isosceles triangle. Write down all isosceles triangles in this figure. We'll take this small one. OBC. So we'll take this one as B. OBC triangle. That's an isosceles. This one, AOB. AOB triangle. That's also isosceles. And when you take this side, AOC. AOC also an isosceles triangle because OA and OC both are equal. Write down all equilateral triangles in this figure. Look at all lengths are equal given. So you can write, we'll take this one, OEF triangle. That's one. So this is one triangle. Identify the other one. OED. This one. OCD. So I can write all these small triangles. BOC. OAB. OAF. Here you know there are more equilateral triangles. What are the other equilateral triangles? Here, can you see? This is also an equilateral triangle. So I only considered small ones. You can write ACE as well. Now in this one, I have connected those triangles as well. Write down all equilateral triangles in this figure. So now I am writing these triangles. So here, this one is an equilateral triangle. And I can show you with this one also. This one is an equilateral triangle. So what are those? ACE triangle and BDF triangle. Those also equilateral triangles. Now look at this one. You have given a big triangle. Write down the equilateral triangle. All sides are equal. Can you see in the middle? 6, 6, 6. APQ triangle is an equilateral triangle. Write down isosceles triangles. You get 3. Look at this one. 6, 6, 10. AQC triangle. And this way, 6, 6, 10. BPA, ABP triangle. ABP triangle is an isosceles. What else? Now, when you take the big triangle, 10, 10 and 18, ABC triangle is also an isosceles triangle. Write down scaling triangles. Lengths are different. So when you take ABQ triangle, 10, 12 and 6, that's a scaling triangle. ABQ triangle. And this way I can take APC triangle. ABC triangle. This is 12, 6 and 10. All lengths are different. Find out total length of the wire to make this figure. So you need to add everything together. We'll first find out outer one. 10, 10, 6, 6, 6, 18. And middle two, 6 and 6, 12. So all together, 8 plus 2, 10, 1 remaining, 2, 3, 4, 5. 50 centimeters you need to make this full triangle with a wire. Look at this one, write down an equilateral triangle. All lengths are equal. Look at ACD triangle. That's an equilateral, 6, 6, 6. Write down isosceles triangles. Two lengths are equal. Look at this one, BDC triangle or BCD. 6, 6, 10. What else? When you take the big one, 10, 12 and 6. So that's not equal. When you take only, you can write down only one BCD triangle. Write down a scalene triangle. Scalene. You get all three lengths are different, means the big one. 12, 6 and 10. ABC triangle. That's a scalene one. So you get only one equilateral triangle, one isosceles triangle and one scalene triangle. Types of triangles according to the size of angles. Now earlier we looked at the length of the sides. Different lengths, scalene. Two lengths are equal, isosceles, and all the lengths are equal, equilateral triangle. Now we are looking at inside angle, interior angles. Look at this one, 70, 60, 50. All angles are less than 90 degrees. So they are acute angles. So when all the angles in a triangle are acute, we call this is an acute angled triangle. So the first type of triangle is acute angled triangle. Now we look at what are right angle triangles. So right angle triangles means when you get one right angle, 90-degree angle, we call that's a right angled triangle. So triangles with 90-degree angles are called right angle triangle. So can we have a right angle, one right angle can be in the triangle? Only when you consider right angle triangles can we have two, 90, 90, that becomes 180. So you can get only one right angle in the right angle triangle. Now we'll look at the third type, obtuse angle triangle. So what is obtuse means? Now look at this triangle. You get 110-degree angle. That is more than a right angle. So if there's an obtuse angle in the triangle, we call it, it's an obtuse angled triangle. Only one obtuse angle can be in a triangle, because when you add 110 and 100 something, you get more than 180. Can a triangle have one obtuse angle and right angle? You can't, because 90 plus 110, it becomes 200, more than 180. So you can't get an obtuse angle with right angle, only one right angle in the triangle. So what's the type? Obtuse angled triangle. Look at this one, 50, 30, x. Sum of angles in a triangle, we know that this is 180. So find the value of x. So how you find out x? We know 50 plus 30 is 80. 80 plus x is 180. So what's x? Subtract 80. So you get 100. 100 degrees. So that's x. What type of triangle is this? 30, 50 and 100. 100 is more than a right angle. That's an obtuse angle. So this is an obtuse angled triangle. Look at this triangle, 80, 70. What's the sum of angles in a triangle? That's 180. Find the value of y. 80 plus 70 plus x is equal to 180. 70 plus 80, that's 150. Now subtract 150, you get 180 minus 150, that's 30 degrees. So 80, 70, 30, all are less than 90 degrees. Less than right angle. So what is the type of this triangle? Acute angle triangle. All are less than 90 and all these angles are acute angles. Look at this one. 40, 50 given. So what is 40 plus 50? 90. So what is x? 180 is the total minus 90. You get 90 degrees. So that's a right angle there. What type of triangle is this? So 90 is there means right angled triangle. Look at this triangle. Write down 3 right angle triangles. When you take smaller one, this is 90. A, B, D triangle. Other side also, this is 90. ACD or ADC triangle. And when you take the big triangle, this is 90 degrees. ABC triangle is also a right angle triangle. Look at this diagram. Write down 2 right angle triangles. Can you see this is 90? OAP triangle. This is also 90 given. OPB triangle. Those are 2 right angle triangles. Write down obtuse angle triangle. If this is 30, this is 30. What is this angle? 30, 30, 60. 180 minus 60? 120. So this angle is 120. That's an obtuse angle. So AOB triangle is an obtuse angled triangle. Look at this one. Write down 4 right angle triangles. Right angle. So here you get this one. So that means you can write smaller one as well as the bigger one. APQ. And then you can write APQ, ABQ. ABQ. Another one. I'll write down the third one here. Other side. AQR. Because this is 90 degrees. AQR triangle. And the fourth one, I can write AQC triangle. So those are the right angle triangles. Write down 2 obtuse angle triangles. Look at carefully and see. where you get obtuse angle. Think about this one. This one and this one. 40, 40, 80, 80 plus 20, 100. So that's an obtuse angle. This one. So ABR is an obtuse angle triangle. Then other way round. Other way round, that's APC triangle. 40, 40, 80, 80 plus 20. This is an obtuse angle. So APC triangle also is an obtuse angle triangle. Obtuse angled triangle. Write down an equilateral triangle here. These three lengths are equal, ABC. Write down a right angle triangle. Can you see this is right angle? BCD. Write down two isosceles triangle. Isosceles triangle, can you see? This one, this length, and this length. ABD. ABD triangle. And what else? What's the other one? This is also right angle as well as isosceles. Can you see this one? This. Two lengths are equal. That's also an isosceles triangle. BCD. Now, what are polygons? We discussed this before. A closed plane figure bounded by three or more straight line segments is called a polygon. Polygon with four sides, we call it quadrilateral. Polygon with five sides is a pentagon. Now we'll see what are the other names for the polygons. So the minimum number of sides is 3. So you can make a closed figure minimum with 3 lines. That's a triangle. Name of the polygon, that's a triangle. 4 sides, quadrilateral. 5 sides, pentagon. 6 sides, what you call hexagon. What you call 7-sided polygon, heptagon. 8 sides, we say octagon. 9 sides, nonagon. And 10 sides, decagon. 11 sides, have you heard about that? Hendecagon. Hendecagon. And 12 sides we call dodecagon. So up to 12, just remember those names: triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, hendecagon, and dodecagon. Now we'll look at what are convex polygons, and we are learning another one. So what are convex? When joining any 2 points marked inside a polygon. So these are 2 points inside the polygon. When you connect with a straight line, if the straight line lies entirely inside the polygon, then that polygon is known as a convex polygon. So this line is inside. Here also, when you take any 2 points When you draw a line, that's inside the polygon. So that's a convex polygon. No angle of convex polygon is a reflex angle. So when you look at the angle type here, it can be acute or obtuse. This is obtuse, more than 90. So if it's a reflex, we call it another name. So write down the names of the following polygons. A, 3 sides. So we call it triangle. B, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 sides, pentagon. 1, 2, 3, 4 sides, quadrilateral. D, 1, 2, 3, 4, 5, pentagon. E, 1, 2, 3, 4, 5, 6, hexagon. 1, 2, 3, 4, 5, 6, another hexagon. So all these polygons are convex. You are not getting any reflex angle. Now look at these diagrams. These are also polygon, closed plane figures. But when you connect 2 points inside, what happens? The line goes outside the polygon. If there are 2 points in the interior of a polygon such that the straight line joining these 2 points does not lie entirely inside the polygon, then the polygon is known as concave polygons. Look at this one. Points are inside the polygon, but when you connect with a line, that is not entirely inside the polygon. So what are those? Concave polygons. So at least one angle of a polygon is a reflex angle. Look at this one. In this point, this is more than 180 degrees. That's a reflex angle. Here, reflex angle. Here you get 1, 2 reflex angles. Here you get 1 reflex angle. So those are concave polygons. Write down the names of the above concave polygons. 1, 2, 3, 4, 5. That's a pentagon. 1, 2, 3, 4, 5, 6. Hexagon. 1, 2, 3, 4, 5, 6. That's also a hexagon. 1, 2, 3, 4, 5, 6, 7, 8. Octagon. So remember those names. But all these polygons are concave polygons because you get 1 or more reflex angle. In convex polygons, there are no reflex angles, but in concave polygons, there are reflex angles as interior angles. So this is a reflex angle. Here, this is a reflex angle. So those are concave polygons. What are regular? The word regular polygons. A polygon with all sides equal in the length and all angles equal in magnitude is called a regular polygon. Look at this diagram. All sides are equal, all angles 60 degrees. So this is a regular triangle. What you call this? Equilateral triangle. This is a polygon with all sides equal and all angles 90 degrees. This is also a regular polygon, regular quadrilateral. What is the name? It's a square. What is this one? All angles 108 and all sides are equal. So regular pentagon. What is a figure which all sides are equal but not a regular polygon. All sides are equal, but look at the angles. This is acute one, this is obtuse, not the same. So because of that, we don't say this figure is a regular one. So what is the name of this? Rhombus. So rhombus, it's not a regular polygon. Even though all sides are equal, angles are not the same. Look at this figure. Angles are the same, 90-90 each. But this is also not a regular polygon because this length is equal to this length. These two are different lengths. All sides are not equal. So what's that shape? Rectangle. So rectangle is also not a regular polygon. Identify convex and concave polygons. A. All acute angles. Convex. B. 90-degree angles. That's convex. C. We see a reflex angle. That's concave polygon. D. Also we see a reflex angle. That's a concave. In E, we get two reflex angles. So that's a concave polygon. F, all angles, obtuse or acute, that's a convex polygon. This one you get two reflex angles, that's a concave one. This one, all angles less than 90. It can be obtuse angle as well, that's a convex polygon. Construct a regular hexagon ABCDEF with side length 4 centimeters using a compass. So we need to draw a regular hexagon. Hexagon means 6 sides. So what we do, we take the compass and the ruler in your geometry set. So we take 4 centimeter length means we take 4 centimeter length from the compass. So this is 4 centimeter length. So what we do, we draw a circle with 4 centimeter radius. And then we take any point on the circle and draw arcs around. 1, same distance, we took 4 centimeters. 1, 2. You get 6 points. When you do that, you get 6 points like that. 3, 4, 5, 6 point. 6. So you get 6 points. Now we need to connect. Take your ruler and connect all the points. Here to here. One side, second side, 2, 3, 4, 5, 6. So all sides are equal. So 6-sided polygon. So this is called regular hexagon. That's how we construct using the compass. Now we'll look at the exercise in your textbook. This is part 1 exercise. The way a polygon is named based on the number of sides it has is given in the following table: triangle, quadrilateral, pentagon, hexagon. Number of angles. So number of angles is the same as number of sides. So 3 sides are there, so you get 3 angles. 4 sides are there, 4 angles. 5 sides, 5 angles. 6, 7, 8, 9, 10. And number of vertices. So number of vertices also same as number of sides. 3, 4, 5, 6, 7, 8, 9, 10. Copy the table and complete the column named number of angles and number of vertices. Draw a sketch of each type of polygon named in the above table. Name the vertices of each polygon you drew using capital letters of the English alphabet. Name the sides and the angles of each polygon. So draw a sketch of each type. So 1 is done, triangle is done, and 4-sided figure, that's quadrilateral. So we need to draw other shapes. 5, 1, 2, 3, 4, 5. Now 6, 1, 2, 3, 4, 5, 6. 7, 1, 2, 3, 4, 5, 6, 7. 8, 1, 2, 3, 4, 5, 6, 7, 8. 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. I can draw concave as well. And another one, 10. 10 is the last one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I can draw concave or convex anytime. So this is A, B, C, triangle. A, B, C, D. When you are labeling, always go either clockwise or anti-clockwise. A, B, C, D, E. A, B, C, D, E, F. A, B, C, D, E, F, G. Here A, B, C, D, E, F, G, H. A, B, C, D, E, F, G, H, I. Here A, B, C, D, E, F, G, H, I, J. So those are 1, 3 to 10. All are polygons. Angles also we have to mark. 1, 2, 3 here. 1, 2, 3, 4 angles. 1, 2, 3, 4, 5 angles. 2, 3, 4, 5, 6 in a hexagon. 1, 2, 3, 4, 5, 6, 7 in heptagon. Octagon. 8. 1, 2, 3, 4, 5, 6, 7, 8. Nonagon, you need to get 9. 1, 2, 3. 6, 7, 8, 9 angles. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's a decagon. Cut 4 strips of paper of breadth around 5 cm by folding each paper appropriately. Make a triangle, a quadrilateral, a pentagon and a hexagon and cut each shape out. Paste these shapes in your book. That's an activity for you. So you take a paper, 4 strips of paper of breadth 5 cm by folding each paper appropriately. Try to make a triangle, quadrilateral, pentagon, hexagon and cut it and paste it in your book. Exercise 14.2. Draw a concave polygon with 1 reflex angle, with 2 reflex angles and 3 reflex angles. Name each polygon based on the number of sides. So any concave polygon with 1 reflex angle. So we'll try to draw with 1 reflex angle. 1, 2, 3, 4, 5, 6. So 1 reflex angle. So this is reflex angle and 6 sides are there. Name each polygon. So hexagon. And we need to draw 2 reflex angles. We'll try to draw 1, 2, 1, 2, 3, 4, 5, 6, 7. Now, what's this? 7 sides, heptagon. How many reflex angles are there? 1 and 2. 2 reflex angles are there. So, heptagon. So, we need 3 reflex angles as well. 1, 2, 3, 4, 5, 6, 7, 8, 9. What's that? 1, 2 and 3. 3 reflex angles are there. So 9 sides, nonagon. So you can draw any polygon that you like. State 2 facts that distinguishing a triangle from the other polygons. So when you take a triangle, that's the polygon with minimum number of sides. Polygon with minimum number of sides. That's a triangle. And then you can't get a reflex angle in a triangle. No reflex angles. In a triangle. Why? The sum of angles in a triangle is 180. So you can't get more than 180 angles. So no reflex angles in a triangle. Exercise 14.3. Use the data in the below given polygons to complete the table. A to H. Convex or concave. Identify, is it regular? If it's not regular, the reason. Take first one. That's convex because no reflex angles. Then is it regular? All sides are equal, all angles are equal, regular. If it is not regular, the reason. But here all angles and all sides are equal. B, it's all 90 degrees, convex. Not a regular one. Lengths are different. Not regular. You can write lengths are not equal. C, all lengths, all angles are equal. All angles 90, that's convex. So that's regular, all sides and angles equal. The other one, you get a reflex angle. So concave. So is it regular? No, different angles are there. All sides are equal, but so not regular. Angles are not equal. This one, all sides are equal and you get reflex angles as well. So that's concave. So not regular. Angles are not the same, even though all sides are equal, angles are not the same. F, all sides are equal but angles are not the same, and here all are obtuse or acute or 90 degree angle, so convex. So not regular. Angles are not the same. Angles are not equal. This one, all sides are equal but angles are not equal. All angles less than 180. So convex, not regular. Angles are not equal. H, obtuse and acute angle, so that's a convex polygon. So sides are not equal and angles also not equal, so not regular. Lengths and angles are not equal. Both are not equal, lengths as well as angles. Create various polygons by folding a piece of paper of length 50 centimeter and breadth 5 centimeter using a pen. Draw straight lines along the folds. Name the polygons you obtain. So this is another activity you can do. You take a piece of paper, breadth 5 centimeter, length 50 centimeter. So use a pen and draw lines and fold it and cut it. And name the polygons you obtain. So you can do that as an activity. So this is the end of part 1. A closed rectilinear plane figure consisting of 3 or more straight line segments is a polygon. No interior angle of a convex polygon is a reflex angle. At least one interior angle of a concave polygon is a reflex angle. A polygon with all sides equal in length and all angles equal in magnitude is called a regular polygon. Now we'll look at the part 2. So part 2, we are identifying acute, right angle and obtuse angle triangles. We did that, and we are trying to do the exercises in part 2, and also equilateral, isosceles and scaling triangles. Exercise 14.4, examine the below given triangles and state whether each triangle is an equilateral triangle, an isosceles triangle or a scaling triangle. Look at the lengths. 6, 6, 4. Two sides are equal. Isosceles triangle. 6, 8, 10. All are different. Scaling triangle. 5, 13, 12. All are different. Scaling triangle. 7.5, 6.97. All are different. Scaling triangle. 7, 7, 7. All are equal. Equilateral triangle. 3.5, 3.5, 3.5. All are equal. Equilateral triangle. 6.5, 6.57. Two sides are equal. Isosceles triangle. 7.5, 7.5 and 6.3. Two sides are equal. Isosceles triangle. Complete the table. Lengths are given. 6, 3, 6. Two sides are equal. What's the type of the triangle? Isosceles. 4, 4, 4. All lengths are equal. Equilateral triangle. 3, 6, 5. All are different. Scaling. 5, 6, 8. All are different. Scaling. All equilateral triangles are isosceles triangles. Do you agree with this statement? Give reasons. Equilateral means all sides are equal, not isosceles. So this is false. So not true. Equilateral means all sides are equal. And not only two sides equal. So that's not an isosceles triangle. A quadrilateral is shown in the figure. Name according to the lengths of the sides the triangles that are obtained by joining only AC. We'll join AC. So you get triangles. So what are the? Name according to the lengths of the sides the triangles that you obtain. AB, BC, AC, all are different. So ABC is ABC triangle is a scaling. Then when you take ADC, also all three lengths are different. Scaling triangle. Now those are the two triangles you are getting. Now join BD only BD. So you have to consider the other. Now only BD we can connect. So what are the triangles you are getting now? This and this. So you get ABD triangle. Two lengths are equal, so you get isosceles. Look at the other triangle, you get BCD. This length is equal to this one, so isosceles triangle. So when you connect AC, you get scalene triangles. When you connect BD, you get two isosceles triangles. Question number 5. By folding a rectangular shaped paper, create an equilateral triangle and an isosceles triangle. Cut these triangles out and paste them in your book. So again, another activity for you. So you can do by folding a rectangular shaped paper. Create an equilateral triangle and an isosceles triangle. Cut these triangles out and paste them in your book. So what you can do, you can take a rectangular shape paper like this, and here you have to create equilateral triangle. Means all lengths are equal like this. You can cut it. Isosceles means two lengths are equal. So you can take this height and this height both equal, and you can cut a triangle like this. So that's an isosceles triangle. So you can do that and you can paste it in your book. Exercise 14.5. By considering the data in the below given triangles, classify each of them as an acute angle triangle, right angle triangle, or obtuse angle triangle. Look at the angles inside. 50, 70, 60, all are acute angles. So this is acute angled triangle. 90 degrees there. So that means right angled triangle. (120) more than a right angle. Obtuse angled triangle. (60, 60, 60). All angles are equal. We call it equilateral triangle. 140 is there, more than right angle. Obtuse angled triangle. 40, 80, 60, all are less than 90. Acute angled triangle. 42, 48, 90 is there. One angle is 90. That means right angled triangle. 50, 89, 41. All are less than 90. Acute angled triangle. Classify each of the triangles given below according to its angles. Here, 90 degrees. Right angled triangle. That's A. B, all acute angles are there. Acute angled triangle. C, one obtuse angle there. Obtuse angled triangle. This one obtuse angle is there. So that means obtuse angle triangle. Then these all are acute angles. Acute angle triangle. So by looking at the angles, we can name these triangles. Do the following by considering the given figure. Name 3 isosceles triangles. Two sides are equal. Here, when you take the small one, I can write AED triangle. These two lengths are equal. And other side, ADF triangle. These two lengths are equal. And we need another one more. Take AEF. This length is equal to this one. AEF triangle. Name 2 right angle triangles, 90-degree angles. One is here. So ADF triangle, this one, or I can write ADC. ADC also. ADC. If this is 90, this is also 90. You can write down the other two as well. Name an obtuse angle triangle and a right angle triangle having AB as a side. So AB as a side. Obtuse angle. Can you see? This angle is more than 90 degrees. So ABE is an obtuse angle triangle. Then right angle triangle ABD, because can you see this is 90 degrees. So one obtuse angle triangle and a right angle triangle. Name a scaling triangle. You can take the big one. ABC triangle is a scaling. All sides are different. Do the following using the data in the figure. Name 3 isosceles triangles. Two sides are equal. Can you see this one? PQT. Because PT is equal to PQ. When you take other way around, PQR. PQ is equal to QR. And one more, I can take TSR triangle. This length is equal to this length. Name 2 scaling triangles. All lengths are different. Look at carefully. Here I can write PTR. PTR triangle. Sides are not the same. What else? I can write this also. SQT. SQT triangle also scaling. Name 2 convex pentagons. Pentagons means 5-sided figure. 1, 2, 3. So here I'll take 1, 2, 3, 4, 5. That's a pentagon. So I can write PQRST is one convex pentagon. Now we need another one convex pentagon. Can you see that? 1, 2, 3, 4, 5. I can write that pentagon. What's that? ABCDE is another 5-sided pentagon. So no reflex angle. So that's a convex pentagon. Name 2 concave pentagons. Concave means you can get reflex angles. So we'll check starting from here. 1, 2, 3. 1, 2, 3. Here 4, 5. You get one reflex angle. So you can give that one. PTSRT. That's a pentagon. Another pentagon. We'll take this one. 1, 2, 3, 4, 5. We need 5-sided pentagon. That means I can write PAQST is another concave pentagon. Now name a hexagon. That means any hexagon, 6-sided figure. I'll take red color. 6-sided one. 1, 2, 3, 3. We need another 3. 4, 5, 6. 6-sided figure, that's a hexagon. I can label it PQBRST is a hexagon. So we covered second part of this lesson. So what did we discuss here? All 3 sides of a triangle are equal in length, then it is an equilateral triangle. If any 2 sides are equal, we call it isosceles triangle. If all 3 sides are not equal, that's a scaling triangle. In a triangle, if all 3 angles are acute, then it is an acute angle triangle. If one angle is right angle, this is right angle triangle. And if one angle is obtuse, we call it obtuse angle triangle. So practice all exercises and example in both parts.